Hi, my name is Gagan and I'm a consultant in DEV6. In today's DEV6 TV broadcast, we'll be talking about Electron Bootcamp. So if I have to summarize Electron in one line, it will be from their official website. That is, if you can build a web app, you can build a desktop app. And it's easier than you think. So let's start today's session and see how we can use Electron to create a beautiful desktop app. Learning Electron with DEV6. The course objectives of Electron Bootcamp course will be to teach the students to create modern desktop applications using Electron, and this will be the course roadmap. We have divided the entire course into 5 modules. So the first module is Introduction and Installation, and after that we will be touching upon the application architecture of Electron, have a big 100-feet view onto it, and then we will be picking up some of the important Electron features. Once done, we will pick up the Electron APIs. We'll go through some of the important APIs which will be handy during the development, and the last module will be the Electron Userland. So Electron Userland are the important tools which will help the developer to make the journey easier from dev to production. Meanwhile, along with these modules, we have some labs designed, and during the entire course we will be making a fully functional Electron app which was named as Shirtastic, and this lab will consist of the environment setup for the Electron development. And once the environment setup is done, we will turn an existing JavaScript app into an Electron app, and later on we will be adding native notifications, some file read operation, native menus, HTTP communication, and then we will tackle some advanced features of Electron like crash reporting and generating installers. So these are the really cool things which we'll be looking in the labs. And as part of our last lab, we will set up the Electron app for hosting and consuming auto updates. You should have a fairly good understanding of HTML and CSS, some basic understanding of JavaScript, and obviously no prior understanding of Electron. So here we go, the first module, Introduction and Installation of Electron. So before that, we will see what is Electron. So Electron, it's an open source library developed by GitHub for building cross-platform desktop applications with HTML, CSS, and JavaScript. So as a core, you just need HTML, CSS, and JavaScript knowledge to develop a fully functional Electron app. And along with this, when we talk about Electron, the biggest selling feature of having Electron is it gives you Node integration to your desktop app. That means you will have the full control of your low-level operating system where the app is running, and you can make use of all the operating system features, like you can access the file, you can access the camera, you can pick up the microphone. So all that cool things you can do in the Electron app. And how Electron actually accomplishes it. Electron accomplished this by combining Chromium and Node.js into a single runtime. And as a output of it, your app can be packaged for 3 platforms: Mac, Windows, and Linux. So I would like to tell you a little bit more about Chromium here. So the Chromium, when we talk about it, it is the open source part of Google Chrome browser, and it is the open source project, and it's maintained by Chromium project team. And as we talk about Chrome is maintained by Google itself, so we should not confuse between Chromium and Chrome here. So when we talk about Electron has Chromium in it, which is the rendering library. So there's a misconception that along with Electron you get Chrome, but that's not true. You just get the Chromium rendering library, and by adding just the Chromium, you keep Electron as lean. And when we talk about Node.js, as we all know, it's powered by V8 engine, which is again Chrome's JavaScript engine. So you have Chromium for the front end and Node.js as the back end. So when you club both of them, that becomes the Electron. And as you can see here, a nice tuning is going on between the front end and back end of Electron, which is like powered by Chromium and V8 engine at some level. So it's like a power pack available to you for making a beautiful desktop app using Electron. And here on the screen, we are talking about some important milestones in the history of Electron. And as we can see in the top, it's 2013, so that means it's not that old. It's still new. And in 2013, Electron began as the framework on which Atom was built. Originally, it was called as Atom Shell, and it was developed by Sheng Zhao. So Electron was built for developing the Atom editor. And later in 2014, Atom and Atom Shell both got open sourced. And in 2015, Atom Shell was renamed to Electron. So Electron got its name in 2015. And in 2016, first version of Electron was released. And here we are talking about why desktop apps instead of web apps. So that's the main thing which comes into mind. Like, everybody is writing web app. Why should I even pick up the desktop app? But there are some important reasons that you should think of before picking up desktop app and as Electron to make this desktop app. So the first reason can be constant connectivity with internet. So if you have a desktop app, it's really not required to connect with the internet all the time. And with the desktop app, you get your beautiful shining dock icons, you get desktop shortcuts, keyboard shortcuts, you have a native feeling, native notifications are there, native menu is there. There's so much more to a desktop app instead of a web app. And then again, hosting is really cheaper. And in the lab, I will show you how hosting is done, and it's really cheaper than as compared to the web apps. And as when you're creating a desktop app, you will obviously work with peripheral devices and other local hardware, and which cannot be done in web app, I believe. And when we talk about desktop app, then it will be available in App Store. So desktop apps are definitely making a comeback. So we can really invest on learning Electron or other frameworks which help us writing desktop apps. So why use Electron? So as I told earlier, we have some important reasons in order to pick up Electron as the framework. One of the most powerful reason is it has single code base, and it's going to support 3 platforms, which is Mac, Windows, and Linux. And it's an open source maintained by GitHub team. And we have automatic update mechanism here. So you can actually host your updates. There are many ways to do that, and it's very easy to set it up. It's not that difficult. And as we talked earlier, code once, distribute everywhere. You have native menus and notifications. Crash reporting feature is there. Debugging and profiling is really easy here. You need not to learn again. It's the same Chrome developer tools which you'll be using. And Windows installers and the entire deployment and build process is so easy. It's well documented, well maintained, and it's just an npm line away to actually do the deployment and create the installers. So it's super easy. And this is my favorite screen where we talk about the famous apps built on Electron. So I believe everyone can point out their favorite apps here. Mine is WhatsApp. So WhatsApp, Slack, Skype, WordPress, Postman, the famous Atom Editor, Visual Studio, Brave Browser, Jibo. There's so many endless apps which are being built on Electron. And Electron homepage there has a link to the apps which are built there. And maybe you will also end up making a desktop app of your own. You can submit your link there. And as you can see, like, still the framework is not that old, but we have really solid products out there in the market which are created on Electron. So it's a good bet to create and pick Electron as your choice of framework. And here we come to the installation part. So installing Electron is super easy. It's just, as I say, npm line away. So you just do npm install Electron save dev, and there you go. You can start creating your Electron desktop app. It's super easy, right? And you can obviously do a global installation for the same by using a -g flag. And that's it. Yeah, installation is done for Electron. And yes, here we come with the first exercise, which was environment setup. So we have the entire lab ready with us, which has the steps, how to like the detailed steps, how we set up the environment. If the student is new, I mean to say, like if they doesn't have Node or npm installed, we will start from there. We will set up the GitHub, as we have hosted our lab on GitHub. So we will run across all those steps in our Word document, and after this exercise, the student's machine will be ready for creating the Electron app. And here we come to our second module, where we will understand the Electron application architecture. We will have a brief look of how Electron is actually made and what all parts make it Electron. So this is the simplest architecture diagram I can come up with, and which talks about three important pillars of Electron. The first one is Chromium, which will be used for making the web pages, and second will be Node.js, as we spoke about earlier, and which will be used for your file system and networks, or maybe you can think of it for talking to the underlying operating system. We will be using Node.js. And the last but the most powerful is native APIs for three systems. So when I talk about native APIs, this component, the third component, it is a thick layer of C++. This actually does the hard work for you. That means the actual native implementation for the common system operations, like sending notifications, accessing your system preferences, creating your native dialogues, all this is done by this thick layer of C++. And it also ensures that if the developer is stuck with a complex problem which you cannot solve in JavaScript, let's say, you are not just bounded to JavaScript. You can actually use any component which is written in C or C++ or Objective-C, and you can hook your code into it and can solve the problem easily in your choice of language. So when you combine all these three pillars, Chromium, Node.js, and native API, there you go, you get your powerful Electron, which is fully loaded and ready to use for creating your Electron app. And we will have another screen where we are talking about how Electron desktop app, how it looks like. So in Electron world, it's actually divided into two parts. You can actually think it of as a two parts. So one is your main process, and the second is your render process. So when I would talk about main process is the one where your Node.js is running. So that is the main process which is talking to the underlying operating system. You can think it of like that. And render process are the one where your front-end code is running. That is your Chromium, the rendering library. So you have to start thinking in terms of two processes always, main process and the render process. And as soon as an Electron app starts, that means the main process will kick on and it will create a new window or a web page. That is your render process. And then on, the communication starts between the main process and the render process, or we can put it in other terms, the Node.js and the Chromium. And one more thing, like in the diagram, if you see, I have created three render processes and there's one main process, right? So obviously Node.js, that's gonna stay as the main process for your app, and you can have different render process. So in other words, you can say you can have three different windows for your desktop app. So those three different windows are going to run in their own process, which is your render process. And now over the time, they have to pass on some kind of communication or information between each other. So in entirety, it always works like this, that the main process will communicate with the render process, or render process will communicate between main process. Usually one render process will not communicate with other render process. That means two windows will not talk to each other directly. They will go via main process, and that's how the communication will happen. So you pass on the message to main process, it will pass on the message to render process. So yeah, it sounds kind of confusing in the beginning, because here in the start we are starting to think in terms of two process. That means we are starting to think of our desktop app divided into two kind of regions. One is the Node.js and another is the render process. So in entirety, in the entire development, you will be passing messages, passing communication between your Node.js and the Chromium pages. So and all this, the communication is actually facilitated by the Chromium's multi-process architecture. So it's really good, it's really easy. I hope it doesn't sound it so complicated. So that and once we read about how the APIs help us in actually doing it, I'm sure if there are any doubts, it will be cleared at that moment. So here we end our second module, and at the end of the second module, we will have our exercise where we will actually turn an existing JavaScript web app into an Electron desktop app. And it's actually straightforward. It's just 3 steps and boom, your Electron app is ready to be served. We have a full lab on it, and with the steps mentioned in the documentation step by step. So it's easy to pick it up. And here we start our third module, which are the Electron features. So I'll be talking about what are the benefits of if you are using Electron as a choice of framework for your next desktop app. So the first and most important feature is it supports 3 platforms. So that itself is the biggest thing I can say. And as you can see, these 3 shiny icons, so which is your Windows, Mac and Linux. So once the app is written, it's gonna be code once distribute on these 3 platforms. So how cool it sounds, right? So you are just writing code in one language, and the same code is gonna run without any changes on 3 platforms. I'm just like sold over here itself. And it's gonna be reusable. By reusable, I mean you can actually run the same code for, if you want to plug it out, you can run that code as a web app, and the same can be hosted as a desktop app. So if organized properly, you can reuse your code. That means you can host your web application and desktop application using the same code. How cool it sounds, right? And the second feature is code and app management. So again, I can like talk for like 30 minutes on this slide itself, that how the life gets simpler if you're using Electron. That means you will have a single requirement document, because you're creating a desktop app. You need not to worry about all those browsers or all those different kind of hacks which you have to put in order to make it look similar on the various platforms. So, and you will have single team, because we don't need experts in iOS or Android, another thing. And you will have single code base, cost and time, obviously it will be saved if you use it. And I can also quote some very interesting examples how small the teams are behind famous Electron applications. So if you think about Microsoft Visual Studio Code, like every other developer uses this software, right? And it was just built by 7 engineers. So there itself, the claim is like proved, like such a small team can develop such a powerful app which is used everywhere. And Slack desktop app was again created by just 2 developers, and GitHub's desktop app was again created by 4. So there itself, like these are the battle tested softwares out in the market, and how small the team can be, how simple the entire process can be if you are using Electron, right? And the next feature, which is again very important, the low level hardware accessibility. That means if you're creating an Electron app, you will have the keyboard shortcuts. You can create your you can have access to the microphone, keyboard, camera, everything, which are which actually is done via Node.js, right? So like how we told, through the main process. So you're gonna get hold of all these features of your underlying operating system, and you can make some interesting features in your desktop app using this. And here we go to the next one. This feature is talking about the native menus and notifications. That means when you are creating your desktop app, you have the power of creating native menus. That means it will have the look, feel, sound of your native operating system where the app will be running. So it's again coming with the Electron, and Electron actually uses HTML5 notification API in order to make it work. And I forgot to tell you that Electron documentation is excellent. So you need not to go through various articles. If you just hit to the Electron documentation, their homepage, they have excellent documentation which talks about all the APIs, how to use it with good example, code snippets, easy to copy and start from there itself. Okay, the next one, mine very interesting, is crash reporting. So crash reporting features helps submit crash reports to a remote server. That means if you are launching your desktop app and for some reason it's gonna crash, right? We have to accept that. And with this feature enabled there, you will have a good report why it crashed at the your user site, and where it crashed you can actually read through it, and you can analysis, fix it. So all those features are very handy, and it really doesn't take much time to set it up. We have a lab on it, and it's really very quick and easy, and you need not to pay for anything, I'm going to say any hosting thing or anything. It's free to use. And on the actual documentation page for crash reporting on Electron's website, they have some famous projects available which they claim to reuse. You can use that based on the use case of your project, and you can have the crash reporting feature enabled in your app. And the next is very important for all the developers: debugging and profiling, right? When you are creating an app, we have to debug it, right? We are not superheroes. We're not going to get it done in the first hit. So the debugging and profiling is a very handy feature, and there is no learning curve here because we are talking about a Chrome developer tool, right? I use Chrome all the time for my development, for testing my web app or the desktop app. So it's the same developer tools which we are going to use it here. So there is no need of understanding a new debugging cycle for your Electron desktop app. It's the same old, our favorite developer tools, Chrome developer tools, handy there. And here an important thing I want to highlight is when we're talking about debugging and profiling, again we have to think in the Electron terminology. That means you have to maybe debug a main process and render process. So when we're talking about debugging main process, so main process is a node process, right? So in order to debug that, you can always use Visual Studio Code to debug it, or how you use your old command prompt, right, to debug the node process. And when we are talking about the render process, which is your front-end code, you can always use developer tools. So it's as simple as that. That you already know all this, how to debug, so you are good to start. And yes, so this is very important feature, which is security. So the main highlight here is that when you are running a web application, you are running on a famous browser. Browser is already kind of doing hard work for you. It's trying to protect the user from all the security or all the threats out there. But here, when we are creating an Electron desktop app, all that security and responsibility comes to you as a developer. You have to take care of it. So it's like with great power comes great responsibility, and you have to really spend some time and think through how you can actually make your desktop app secure and safe to use. So I hope I did not scare you by saying all that, but yeah, it's really important. And Electron team has really good security recommendations, which are like they're covering all the bases. If you just follow on their website the recommendations given by them, I'm sure you're good to go with your next desktop app, and it will be safe for the users to do, and it will be protected from attackers. So they have some really good examples what all security things you have to keep in mind. I will not go through all of them. It's quite a big list, but definitely visit their website to read more about it. And yes, another selling part of Electron is automatic updates. It's so easy to set it up. It's like just like 2 lines of code and you are good to go, because Electron is coming with built-in Squirrel framework and auto updater module. That means it's already doing all the hard work for you. You have to just do 2 steps here. First is you have to set up a mechanism to host the updates. That can be done anyway. There are so many ways to do there. And once you are hosted your updates, second part is turn on the updates in your Electron desktop app. It is already done by the auto updater module. You have to just start receiving it. So it's as simple as that. And we have a dedicated lab on doing it, so we can go through the steps in that. And I will just give you a brief overview that what kind of use cases are there out there depending upon the project. So for example, if your app is a public GitHub repo, there is different way of consuming the auto updates. That means there's already a built-in kind of free web service provided by the Electron team. You can use that and consume the auto update. If it's a private repo, there is another way of doing it. You can use your own dedicated server where you want to host the application. There are so many products out there. Something like Hazel is there. I tried it. It's really easy to use. And so depending upon the use case and scenarios, there are ways of hosting updates, and Electron documentation is covered. They are talking about all the use cases with good examples covered out there. So you are all sorted here. And yep, so in this lab exercise, we'll be covering how to set up your the development tools and the what all features we just spoke about, like native notifications or the menu or crash reporting. All these things we'll be covering in these 2 labs. And here we are reaching to our 4th module, which is Electron APIs. So before we dig deep into again various kinds of APIs, I would like you to remind you of the 2 worlds which I was talking about. I think I'm reminding you very often, but yes, in Electron you have to think in 2 worlds: main process and render process. So here I'll be first covering the APIs which are available in the main process, and then I will talk about the APIs which will be available in the render process. And obviously we have some APIs which are available to both of the processes. So let's start with the main process APIs. So in the main process APIs, I'm covering only few. There's a big list out there on the Electron website. So I'm just picking up the few of them which I used, or like it's very common to use them in your Electron app. The first of them is app. So when I'm talking about app, I have included a code snippet here, which is again from the Electron documentation. So here app controls the application event lifecycle. That means it's giving you various lifecycle hooks where you can tap into it and write your code depending upon your requirement. And if you see this code, it's just so simple, right? It's like old days, vanilla JavaScript code days coming back. And if you see here in the first line, I have used the required Electron. That means the Electron package, I'm calling it, and calling this app module out of it. and on app.on, that's the way I'm listening to this event. So I'm listening to this particular event here, window all closed. So that means when all the windows are closed, I want to tap in my own function. That means I want to quit the app. So it's as simple as app.quit, and your entire desktop app will close. So there are so many events available there: ready, window all closed, before quit, and so many. So that's how you will be using it in the main process. The next one is browser window. So browser window, we are talking about the various render process, like how you begin. Like in the main process, when you are starting to create your desktop app, you have to call this package out of require electron, and once you have it, you can create the new browser window by giving the height and width, and you can obviously load a third-party URL, or you can load your own index.html, and you can start your application. So this window, browser window, will help you create and control it. And you can, there are so many flavors of it. That means you can create frameless window, you can have parent-child window interaction going on, you can always have model window also. So there are so many ways to do it. And next one, the very important one, is IPC main. So this is the inter-process communication which we were talking earlier, like how if the main process has to pass some messages to the render process, IPC main will be used in the main process. So we will quickly go through this snippet where we are showing how the messages is passed between main process and render process. So for example, in the main process, at the second line, IPC main.on asynchronous message. So you can think that when we have to pass this message, like it's listening a synchronous message, the same message will be listened in the render process. So here in the render process, you are sending the asynchronous message. That means ping is going here and it will print ping, and I'm sending another message from the main process, which is asynchronous reply, which is sending pong to the render process. So here, if I receive the same, just notice the keywords. It's as simple as that. Keep the same event names, and you will get the bong. So it's simple as ping pong going on, and it's not that tricky to set it up. So here we saw on the left hand side was the main process, right hand side is render process, and how easy is there to pass messages between each other. And the next one is dialog. So that means you can create native system dialogues for opening files and alerts. So this is the code snippet showing the same. And the next one, very important one, the menu and menu items. That means when you're creating your desktop app, you have to create some nice native menus to give the look and feel of native, right? So it's very easy to create them. Mainly they are done from the build from template class from menu package. And if you see here, we are creating a menu with first label, and we are creating sub menu as well. That means edit will be the top level, these are the childs of it, and you can obviously like hook some kind of functionality. For example, on edit sub menu 1, we are opening up an external page using a shell API. So it will open up in the new browser window. It will go from the desktop app, go to the browser window and open it there. And next one is power monitor. So power monitor helps you in hooking up to the various states of your operating system. That means if you want to, your application wants to write some important code based on the state of your operating system, you can very easily hook to any of these events. For example, suspend, resume, on battery, on AC, shutdown, lock screen. So all these are so easy to use. So if you can see in the snippet, just electron.powermonitor.on suspend, you can write the system is going to sleep, as simple as that. So here we come to the end of the APIs, some of the APIs which we covered in main process. The list is so big, you can obviously visit the documentation and go through all the main process APIs which are available. Now we will talk about some of the important. I will just cover the IPC renderer here, which are available in the render process API. And let's go to that. This is the IPC renderer. It's the same code snippet which we just saw in the main process. So the key difference here is the name of the API which is available. So IPC main is available, and in the render process the name is IPC renderer. So again, it's the same ping pong depending upon which API you are using. So if you see here is the same IPC renderer.on, you are listening to this message and receiving this message from the main process. So here asynchronous reply, here event.sender in the main process you're sending pong, so it's print pong here. So it's essentially the same communication. You have to use the right name of APIs. So again, I will remind, just focus that you are writing the code in the render process or you are writing in the main process. And so these are some of the APIs which are available in render process. I will quickly come to the APIs, list of APIs which are available to both the processes. That means it is available to the main process also and to your render process. So some of the important ones are here, which is clipboard, crash reporter, native image, screen, shell, synopsis, process, and environment variables. So I have talked about crash reporter earlier. I will talk about native image, which is very important. You will be using it. So native image helps you in creating tray, dock icons, application icons for your desktop app. So you can make use of it. And screen, again, screen is using screen API can be used to retrieve information about your screen size, display, your cursor position, and all these things. So you have like pretty good list of APIs available for adding some nice native features into your Electron app. And the list is so big, like as I told you. I will definitely recommend to go to the Electron documentation and have a look there. So at the end here, we will come to our lab exercise, which will talk about the crash reporting feature, how to set up your app so that it can start collecting crash reports and send to a remote server. So here we come to the last module, which is Electron userland. And I will suggest that do not skip this session, this module, because here we are going to talk about the tools which are required to be set up on the developer's machine in order to make the journey of a developer easy from starting from the development time to releasing into production level. So the Electron official website talk about various, this is a name they have used, Electron userland, where they are listing out all the famous tools out there which are used by a larger number of people, supported by good community. So I have picked a few which I was using in my lab exercises. So a few of them are Electron Builder, Devtron, Spectron, Electron Reload. So I'll go through one at a time. So first one is Electron Builder. I'm sure you will also end up using this because this makes your life so easy. It helps you to package and build a ready for distribution Electron app for 3 environments. So macOS, Windows, and Linux, and auto update support is inbuilt in there. So you need not to do something extra for it. So that means the line is so easy. You just use yarn or npm. You can use npm also. So npm add Electron Builder dev, and it will be saved in your package.json. And in order to create a build, that means a shippable folder for ready to be distribution is 1 line away. So you just use the Electron build script, start it on npm, and it will be ready for you to ship it. And this has the features of code signing also, your auto update, and all these target formats which I have mentioned in the slide is achievable. And the next one is Devtron. Devtron, it's kind of an extension to your developer tools, and Electron team has created this one, and it helps you during the debugging, like when you're sending some messages, that is that IPC communication is happening. It's very easy to see it because it's done in a pictorial way. So it's kind of an extra extension which comes up on your developer tool. So as soon as you install it, so when you're trying to debug your application or view in the developer side, you can see this Devtron tab there. Next one is Spectron. So this tool is also developed by the Electron team, and it is used for writing integration test cases. And it's very interesting. Spectron is built on top of Chrome driver and WebDriver IO. So if I remind you, Chrome driver is the famous standalone server which implements WebDriver's wire protocol from Chromium. That means it is the open source tool for automating testing of web apps across many browsers. So it's like quite like a battle tested and powerful tool. And when I talk about WebDriver IO, that's like a next generation WebDriver test framework for Node.js. So you can see how powerful it can be. The Spectron is like, it's built on top of Chrome driver and WebDriver IO. So you're gonna get so many things out of the box if you're using it. And Spectron, it supports all testing frameworks. So you're not limited to one kind of your choice of language. Let's say you want to write test cases in Mocha, Chai, Jasmine. You can use your existing knowledge and write the test cases using Spectron. The next one, my favorite, is Electron Reload. It really makes the life so easy because hot reload or live reload is very important when you are doing development. That means when you are chaining any of the files, either in main process or the render process, you want to just save it and see your app refreshing in like milliseconds. That saves so much of development time, right? So I will really advise to set up this tool in the beginning as soon as you start your thinking about developing an Electron desktop app. So again, to install, it's easy. It's again npm ecosystem, right? So npm install Electron Reload, and I'm talking about two resets here as it's mentioned on their documentation: soft reset and hard reset. Soft reset means only render process code changes will be available. That means if you change an HTML or markup of any of the front-end page, if you use soft reset, as soon as you change it, type and save, your only the render process will refresh. But if you want the hard reset, that means you want to start a new main process again every time you change the application. So this code snippet you have to use. So it's pretty handy. It's just like how I have written here. Just add these 2 or 3 lines in your main process and you're set. And yeah, here I'm talking about the famous Electron boilerplates, ready to use kind of like these are the GitHub projects which talks about if you have a already Angular project, React project or Vue project and you want to convert it into an Electron project. These are kind of the best practice, or I will say the good project structure which you have to use. And these boilerplates have some of the tools already kind of covered. So previously I was talking about Electron Reload, right? So maybe in these projects they have already included it. So it's kind of good to start. If you are new to Electron, you can always clone these projects and have a feel of how an complete Electron project looks like. To go through the project structure, how it's arranged, get familiar with, and based on your choice you can obviously reshuffle the structure and all, but it's a good point to start from. And here at the end, this is like the last exercise. Here we will be talking about generating installers and automatic updates. So in this lab we will be showing you how to generate the installers and executables for all the 3 platforms, so Mac OS, Windows and Linux. And we will also show how to host the updates and consume it in your Electron app. And here I have mentioned some of the resources which I referred to when I was creating this courseware. So the first and most important, as I told you throughout the course, Electron documentation is really very well written. They have nice samples over there. You will definitely start from there. Once, if you're not able to, if you're stuck on problem, then go to their GitHub issues or the Stack Overflow website. And I also made use of CourseTro articles to get the app up and running. It was really helpful. Let's move to the demo for the Electron Bootcamp courseware. So first I will go through the code structure, how we have organized the folders, and then I will show you the final app which is created for this course material. So here, if you can see, I'm using Visual Studio Code, and yes, it's an Electron app. I love it. And if you see, I have organized the assets, which comprises of entire stuff for my app, which has the CSS, icons, images, JS, and screens. So I have kept it simple. I haven't used any of the frameworks. That means it doesn't use Angular, React, or Vue. It's just a plain JavaScript, vanilla JavaScript app, and the entire material required for that app is kept in the assets. And outside, if you can see, I have package.json, which obviously tells us what all are the plugins or the dependencies for the project. And then we have the main.js. Main.js, if I remind you for the last time, this is the main process which I was talking all about in the during the course material. So this is the Node.js process code which we are talking about, and main.js is the main application which is like the entry point for your Electron app. So, and index.html is again the entry point for your front-end code. So it can be anything, like you can again you can put on your Angular project here or React project and use their index in HTML as the entry point for your main.js, so that existing Angular app or React app can be loaded into the desktop version. And once this is done, so we are using JSON server for hosting all the APIs consumed for our app. And yep, pretty much that's it. If you want to say, I will just go through the package.json once, so that you know the entry point which I was talking about. So if you see here, that's like plain old are things, name, version, description. Then comes the main part. So this is the key entry point which you have to use. So which says you have to look through the main.js file, which is our node process file, and inside the main.js you will load your index.html. So again, at the same level it's there. So main process will create a new browser window for you, and in this new browser window, this index.html will sit and your single page architecture will start running seamlessly. And now I will show the lab, not exactly the lab, the demo for this courseware. And this is the Shirtastic app which I talked about, which will be developed along during the entire course. So starting from welcome screen to the sign up screen, and then shirts catalog, so and then the context us screen, and here I will just go through what all things we have covered as part of this app. So we have created the form here, sign up form, which will, as soon as you fill up your information, you can add some kind of a nice native notification just for the look and feeler. So I'm sure that sign up alert was not covered here, but you heard the sound, right? So this kind of notification that will come as soon as you do the sign up. And then we have the shirts catalog. This is again this information, the t-shirts picture and all, it's coming from our JSON server HTTP API, which we created for the purpose of this lab. So in this part, we will learn how to make HTTP request and how to consume it in our Electron app. And then in the contact us, we are making another browser window where we have another render process. So remember we were talking about one render process, two render process. So as soon as you bring this contactor screen, now we have two render process and one main process. So if they have to communicate with each other, the render process has to talk to main process, and main process will again come back to render process. So in contactor screen, we are covering how to do the file read operations, or something like I can pick up some sky picture or something and open here. So essentially we are showing here the file read operation, that it just printed the entire the path. So that is done. If you put on some name and you say submit, you have that nice native look and feel, kind of an alert. Thanks for your feedback, we'll get in touch soon. So all this is covered in this app, and then plus we are covering the crash reporting, how to perform the crash reporting, and then we will cover the generating installers, and finally we will show you how to do the auto updates. So that's it, and that was the demo for it. So you'll get to know more about it once you sign up for the course, and we will go through the labs, and we will do the guided thing. That means going through every lab in a way with the steps to do it, and by the end of the labs and this course, you will have a fully functional Electron desktop app running on your machines, and you will have the taste of how it's done. Thank you.